So first thing is, how do you get user input into your program without just having to hard code numbers? You don't want to have to edit a program every time you want to run it on a different set of numbers. So what we learned in 1181, we'll actually learn better ways of doing this later on in the course, but the basic way is with the input function. Okay, so this will put a prompt to the command window. Please enter your height in inches. It'll wait for you to enter a number, and then it'll save that number in this variable height. And then the same with weight, and the same with name. So enter your height, your weight, your name. All right, and you can look now in the workspace. You can see those variables have been saved to the workspace. Now, one little detail, you should remember this from before, but people tend to get tripped up on this. We put comma S here because when you enter your name, you're not entering a number, you're just entering text. So you put a comma S to tell MATLAB, this is just a string, don't try to interpret it as a number. If I leave that out, it will not let me enter my name. Okay. Now, actually, with a regular script, you get an error. In a live script, it just asks you again. Now, it turns out you actually can do it. You can just put it in quotes. But you don't want the user to have to put it in quotes. So instead, you just put comma S here. And now it lets you enter a string. Oh, mess that up. Do that again because I'm going to need this number later. Okay. All right, so that's input. That's really about all there is to it. Although there is one additional thing you can do with it. Sometimes you may want the user to enter a set of numbers, enter a set of test scores or something. And it gets really cumbersome having to enter those numbers one at a time. So you actually can have the user enter an array by putting it in square brackets. But there's no special notation for that. The user just has to know to put the numbers in square brackets. And so you can remind him as part of the prompt. All right, so it's saying enter your test scores. So I can just put in my numbers, 98, 93, 81, 79. All right, and it stores those as a row vector. Okay. And then I can do whatever calculations I want to do on that vector. All right, which leads to the next topic, is the review of fprintf. So we want to, as I showed you before, when you display messages to the command window, you want it to be a meaningful message, not just a number that pops up out of nowhere. So there are two ways now of combining text with numerical values. fprintf, which is what you learned in 1181, or now in the later versions of MATLAB, you can do it with disp. All right, so here's an illustration of doing it both ways. Okay, so remember with fprintf, the way it works, everything goes inside single quotes. Your highest and lowest scores are, and every place where you're going to have a value, you put a placeholder. It's called a format descriptor. This just sort of says value to be provided later. And they always begin with a %. All right, so some number is actually going to be printed here, but that number comes later. And remember, the \n means go to a new line, because fprintf will not go to a new line until you tell it to. You can have 5 fprintfs in a row. If you don't put a \n, they will all print on the same line. All right, then you close the quotes, comma, and then you supply the set of values to print out. And it just matches them up with these format descriptors by order. Right? So when it gets to this first one, it looks for the first value that's provided, and that's what goes there. Gets to the second one and looks for the second value. Now these are integers, so the format that you use in that case is %i. Right? So it's that says display it just as an integer, not with a decimal place. All right, then do the same thing with disp. And this is unfortunate, but again, it's kind of for historical reasons that MATLAB sometimes uses single quotes, sometimes double quotes. Here, you have to use double quotes. Right? If you put single quotes, it will treat it as a character array. And as I just showed you a little while ago, it'll then replace each character with its ASCII code. And that's not what you want here. You just want to keep it as a string. All right. And then to join the pieces of the string together, you use a plus. All right. So it's either one is just as good, but you just have to keep the syntax straight. With fprintf, you use single quotes and you separate things by commas. With disp, you use double quotes and you separate things with a plus sign. Okay. But you get the same. And I think I forgot to put the word and here. But you get the same result. Come on, don't hang up on me. Oh, it's waiting for me to enter the numbers. Okay. All right. Okay. Yeah, okay. So I anticipated your question. I had forgotten to put and there. Yeah. Now remember, again, if you're going to do it this way, remember you have to put in the blanks. If I forget to put in blanks, everything runs together. Okay, so you have to put in a space wherever you want one. All right, so either way is acceptable. fprintf, I think, gives you more control over the format. And if you're printing multiple things, I think this method with this gets a little clunky. If it's just like one message and one number, that's fine. But if you're putting a list of numbers, I think it's actually easier to use fprintf. But whichever way you like. All right, here's another example using disp versus fprintf. Okay, so I entered my height and weight earlier. And so I'm calculating my body mass index, and there's the formula for that. So in the old days, before the most recent versions of MATLAB, you could only print out one thing at a time with disp. So you would print each of these on a separate line. And you'd get Jim, your body mass index is, and the number all in separate lines. Okay. Well, now you can combine them all in one line like so. Or, of course, you can do it with fprintf. Now, remember, though, if you don't round off the number, it'll just print with some arbitrary number of decimal places. You should always control the number of decimal places. You should think about what's an appropriate number of decimal places to use here, and you should control that. And if you're going to use this method with disp, the way you do that is with round. Okay, this says round it off to one decimal place. All right, or you can do it with fprintf, same way. Now remember with fprintf, so in the previous example, we had integers, so we used %i. Well, now we're printing out other data types. The name is a string, so we use %s for that. The BMI has a decimal point in it, so that's called a floating point number in computer terminology. So the format for that is %f. All right, so by default, it displays it with all these decimal places. But you can control that. You can tell it how many decimal places by putting %, point, and the number of decimal places, then f. Okay, so this says display it with 4 decimal places, 3, 2, 1. And if you want to display it as an integer, you can use %i, but you have to round it off. Watch what happens. This is a common mistake that we see. If you try to print it with a %i format, but it's not an integer, it reverts back to scientific notation. Oops, it's not going to let me select that. Okay. All right. It reverts back to scientific notation because it says, you're telling me to print it as an integer, but it's not an integer. So what am I supposed to do? Oh, I'll just revert back to some other format. All right, so round it off to an integer if you want to display it as an integer. Okay. Now notice in this case, so I printed it out numerous times with different decimal places, and these are all left aligned. Well, sometimes when you print out a table, you want things to be right aligned. And you can accomplish that by telling it how many spaces to reserve for this number. And that's the number that goes before the decimal point. So this says, print it out with 4 decimal places using 7 total spaces. And people sometimes get confused about that. The 7 is not the number of digits before the decimal point. It's the total number of spaces. Right? So in this case, we have 4 decimal places, the decimal point itself, and 2 digits before the decimal place. So it's already taking up 7 spaces. So 7 is the minimum that you could use. Here, we're only using 3 decimal places, so we only need 6 spaces. But we told it to use 7, so it'll pad it with a blank at the beginning. Here, we only need 5 spaces, so it'll pad it with 2 blanks, and so forth. All right, so when you put a number before the decimal place, however many spaces it actually needs to display the number, whatever's left over, it'll just pad it with blanks at the beginning. And therefore, things come out right aligned. Okay. But usually the only time you do this is when you're printing out a table and you want all the numbers to be lined up. All right, any questions about input, disp, or fprintf? All right, let's try one. Should take you about 2 minutes. Use input to have the user enter a set of numbers, and a second input to have him enter the units of the numbers, the units of measurement, and then take the average and print out a message, something like this. The average of the so many measurements is so many, whatever the units are.